So let's take a look at number 3. Calculate the net torque, magnitude, and direction on the beam in figure 8.3, which we have that copy here, about A, an axis through O, perpendicular to the page, and then B through axis C. So let's tackle A first, right? It says that the axis is through point O. So this here is the point of rotation. Well, remember that torque is force times radius. Well, it doesn't matter how strong the force is. If the radius is 0, which it is in the case of this force here, then that force we can totally ignore because it doesn't cause torque, because it's acting at the point of rotation. So we only have two forces that are causing torque. We have this force here at point C, and remember, it's only the component of the force that's perpendicular to this beam here. And then we have this other force over here, this 10 Newton force, and the only one that is causing torque is the y component of that force. So just like forces, we are going to do the sum of torques instead of the sum of forces. And if we want to find that torque, right, just like the others, it's equal to the net torque, or the total of all the torques. So we are going to have our, let's say this is F1 and this over here is F2. So we are going to have F1 times R1, and R1 is the distance from the point of rotation, plus F2 and R2, right? The problem with that statement is that F1 and F2 aren't perpendicular to it. So the 25 newtons really doesn't work. So we don't want just F1 and F2. We need F1, and because of where this angle is, right, it is adjacent to this force. So we would want F1 cosine 30 degrees, right? And then we would want, oh, oops, I forgot. I've got to multiply that component by its radius, right? Is it plus or minus here on the next one? Well, if we're looking back at these forces here, right, this force that's acting would cause, if this is the point of rotation, would cause it to try to rotate this way, which would be what? Counterclockwise. And this force has a y component that would go this way, which would be clockwise. So they have to be opposite sides of each other. So if F1 cosine 30 R1 is positive, and it really doesn't make a difference which one is positive, which one is negative, but let's say that's the negative one because it's counterclockwise, then we would add it to our F2, and the y component from this angle is opposite side. So the sine of, sine of 20 degrees, and then don't forget you have to multiply it by the distance away from the point of rotation, which is that 4 meters. So really we're just going to plug in our numbers, right? The sum of the torques are equal to F1, which is 25, and we're doing cosine 30, so we have this component that's perpendicular to our beam, and then we're multiplying it by its distance away from the point of rotation, so that's given here at the 2 meters, and then we are adding, because we want this to be negative because it's counterclockwise, we're adding our F2 of 10 newtons, but we need to put in that sine 20 degrees to get that y component. And then don't forget, you got to multiply that by its distance. Well, its distance away from the point of rotation is that 4 meters. And when you punch all of that in, you get, let's see, 29.62 newtons times meters. Right, and so that is your first one. And for part B, well, for part B, all of a sudden we want the axis to go through point C, which means, let's see what that does. Uh-oh, that's not good. So that means that we need to get rid of all this stuff here. Get it out of the way. Sorry, I should have probably paused our video and erased and came back to you, but too late now. So for our B, if the point of rotation is at point C, then that means that this force doesn't cause any torque because it is at the point of rotation. It has no distance. Our 10 Newton force is still pushing down. It would cause it to rotate clockwise. So we're going to say that that's a positive torque. Our O, now it's at a distance away from the point of rotation, our point C, and so it's going to cause torque. We need that part that is perpendicular to the beam, and it's at this distance of 2 meters. Well, it would cause it to rotate this way, which would be counterclockwise, so we're going to say that that's negative. So our sum of torques, if this is F1, is F1, and here's our 45 degrees. The force that we're looking for that's perpendicular to the beam is across from that, so that is sine 45 degrees, and times its distance of R1. Right, and again, we're going to make that negative when we put in our numbers. So plus our F2, if we call this F2, times the sine of 20 degrees, right, that's our force, times the distance, and from this point to this point, right, because it's only the point, the distance away from the point of rotation, that is 2 meters, and that will get us our net torque. So let's plug in our numbers, right, F1 is 30 sine 45 degrees, times our distance away from the point of rotation, which is just this 2 meters here, plus F2, 10 newtons, sine 20 degrees. Again, we just want the y component, so that's why that sine 20 is in there. And it is a distance of 2 meters away. And when you plug all that stuff in your calculator, you get 35.59, and it is torque, so it's newtons times meters. And that is it. That's number 3.